Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 185. Page number 125, problem number 229, the penultimate problem in the series. 229. Let's learn this word we just used. Penultimate problem. Penultimate is a very fancy way of saying second to the last problem. If you're interested in improving your vocabulary along with your math skill, as you and I do the math problems together, if you're also interested in working with me to help you improve your vocabulary, you will find on my channel some vocabulary videos, some vocabulary lessons. And I know we learned the word penultimate because we have looked it up before. Penultimate, we learned it on day number 11. Day 11. Just type in vocabulary, day 11, along with my name, and we'll pipe right up. If you watch that video, you will learn this word along with some other, hopefully some useful and interesting word for you. Second to the last problem is what we're going to do. The question here is, for how many integers that satisfy the inequality that is given to us, which is x plus 2 times x plus 3 divided by x minus 2 has to be greater than or equal to 0 or less than 5. How many integers will satisfy this inequality that are less than 5? That's all they're looking for. Let's see what we can do here. The first thing we need to notice here, I'm going to do it in steps. Step number 1 here. The first thing we should notice here, the first thing we should notice here is that we have greater than or equal to sign. You see, greater than or equal to is greater than or equal to. This equal to sign is very important in this problem. Greater than or equal to sign. So the question we need to ask ourselves is, when does a fraction become equal to 0? When does a fraction become equal to 0? If you have a over b, how can this fraction equal to 0? How can this fraction equal to 0? The answer is when the top is 0. When the top is 0, when the numerator is 0. The bottom cannot be 0. If the bottom were 0, if the bottom were 0, a divided by 0 will be undefined, it will be infinity. A fraction becomes 0 when the top of the fraction, whatever that appears in the top, in the numerator, becomes 0, the fraction becomes 0. And we have to satisfy that condition because it says greater than or equal to, which means that the top has to become 0 somehow. So the question we need to ask ourselves is, when will the top become 0 here? When will the top become 0 here? When will the top become 0 here? Well, let's find out. X plus 2 and x plus 3 will become 0 when either x is equal to minus 2, when x is minus 2, negative 2 and positive 2, this will become 0, and doesn't matter what we have here, 0 times anything is 0. Or when x is minus 3. If x is minus 3, then negative 3 and a positive 3 will become 0. It doesn't matter what we have here, anything times 0 is 0. So we found two answers already. The question was, for how many integers does this inequality hold that are less than 5? Well, negative 2 is less than 5, negative 3 is less than 5. We already found 2. Let's see how many more we can find. Now, so we are done with the first step. Now, In the second step, we will literally go through all the integers less than 5. All the integers. It may sound like a daunting task, but it's not. Trust me. I need the room, so I'm going to start from the top. The expression is x plus 2 times x plus 3 over x minus 2. Let's ask ourselves, can x be, we already found that it can be negative 2 and it can be negative 3. Can x be negative 4? Can x be negative 4? Let's find out, shall we? If x is negative 4, then x plus 2, right here, x plus 2 times x plus 3 over x minus 2. X plus 2, when x is negative 4, the first part, negative 4 and positive 2, will be a negative quantity. A negative 4 and a positive 3 is also a negative quantity. On the top, we'll have negative 4 and negative 2, which is also a negative quantity. On the top, we have a negative times negative, which is positive. On the bottom, we have negative. The whole thing is going to be less than 0, which is not allowed. We are told that this has to be greater than or equal to 0, which it is not here. A positive quantity divided by a negative quantity is not greater than or equal to 0. It is not greater than 0. So we ruled out anything that is less than negative 4. We already have negative 3, we already have negative 2. Let's look at negative 1. Let's look at negative 1. Can x be negative 1? Again, x plus 2 times x plus 3 over x minus 2. If x is negative 1, a negative 1 and a positive 2 is positive. A negative 1 and a positive 3 is positive. But in the bottom we have negative 1 and a negative 2, which will give us negative. So on the top we have some positive number, on the bottom we have some negative number. The whole thing is equal to negative, which is not greater than or equal to 0. X cannot be negative 1. Can x be 0? Can x be 0? See, we're going in sequence, you understand? We're going in sequence. We already have negative 3 works, negative 2 works, negative 1 did not work, 0 did. We'll find out actually. We haven't done 0 yet. I should have crossed it out. We haven't done 0 yet. Let's do 0. 0 is very easy. When x is 0, we have positive 2 here. So that's a positive quantity. Again, when x is 0, we have positive 3. That's positive. When x is 0, we have 0 minus 2, which will be a negative quantity. We'll have positive over negative, which is not greater than or equal to 0. Positive divided by negative is negative. It cannot be 0. Can it be positive 1? Let's find out, shall we? Can it be positive 1? Of course, it's taking some time because I'm explaining everything, but when you do it on your own, it should go quite rapidly. Can it be negative? Can it be positive 1? When you say can it be positive 1, we don't literally put in positive 1 there. That'll be a waste of time. We're just interested in the signs. Can x be positive 1? Well, if x were positive 1 and positive 2 is positive. Positive 1 and positive 3 is positive. Positive 1 and negative 2 is negative. Again, we'll end up with positive on the top, negative on the bottom, which is whole thing is negative, which is not greater than or equal to 0. X cannot be positive 1. Can it be positive 2? Can it be positive 2? To which the answer is a resounding no. Because if x were positive 2, on the bottom we'll end up with positive 2. On the bottom we'll end up with x plus 2 times x plus 3 over positive 2 minus a negative 2. We'll end up with some number on the top over 0. Any number divided by 0 is undefined. It's undefined. We cannot divide any number by 0. it cannot be positive 2. Can it be positive 3? We are almost done. We have to do positive 3 and positive 4 and that's it. We are done because it has to be less than 5, we are told. The integer has to be less than 5. Can it be positive 3? Can x be positive 3? Well, let's find out, shall we? Positive 3 and a positive 2 is going to give us a positive quantity. 3 plus 3 is 6, which is a positive quantity. On the bottom we'll have 3 minus 1, which is a positive quantity. Ah, voila! So that's positive and that is greater than or equal to 0. It's not necessarily equal to 0, but it is greater than 0. 3 works. Aha! We found one more winner. We have a third winner. Can it be positive 4? Let's find out. Can it be positive 4? Of course, by now you're getting a hang of it. Can it be positive 4? 4 plus 2 is positive. 4 plus 2 is 6. 4 plus 3 is positive, which is 7. And the bottom we'll have 4 minus 2, which is a positive. Again, the whole thing is positive. It is greater than or equal to 0. Positive 4 also works. Positive 3 also works. Aha! And of course, we cannot go up to 5 because we had the problem the way it reads it. I'm going to read the problem to you one more time so that we know where we're going with it. It says, for how many of the integers that satisfy the inequality are less than how many of the integers? You see how many of the integers, they have to be whole number, are less than 5. So we have to stop at 4. That's it. There are only 4 numbers. Negative 3 works. Why did negative 3 work? Because negative 3 makes the top 0. And that is the part that has to come with the equality sign. Negative 2 works because again that makes the top 0 and that has to do with the inequality. So we found 4 answer choices. 2 of them has to do with making the numerator 0 and the other 2 has to do with the fact that it makes the whole fraction positive. That's all. There are only 4 of them. I will see you tomorrow, okay? Bye now.